verify that given functions are yes. What was that? Yes. Fc is equal to c square, not magnitude, c square plus c. Yes. And the second exercise was minus c. Third was yes, sine 2c. Okay, so these are the functions we have to verify that are a function that are analytic or not analytic. Okay. I have already explained. Analytic function means if you have defined the domain in complete domain, if they are differentiable and continuous, that will be defined as an analytic function. And we have there is a one theorem, that is if you write that every function f, I have already explained, every function f c, whatever the complex function, that may be write as a real plus imaginary part of c, or you may say that fc is function of alpha, beta. Sorry, they may write I have already explained every function of complex may be write as a r alpha beta, okay, plus iota a r iota alpha beta, okay, where both are real. Okay, and they are a four-dimensional because two-dimension of this and two-dimension, and that will be, and where c is alpha plus iota beta, and this is also real. These are also real. These are the also real, but x's are imaginary. Yes, and for analytic function, I have already explained that according to Cauchy-Riemann theorem, okay, theorem. That was this, yes. Beta. Yes, I remember. If you remember that, okay. So may I erase it? This was. So firstly we have to write first solution. So I start from 1. Okay. Fc is equal to C square plus C, and C is as I have already explained, C where C is alpha plus iota b beta square. So Fc will be alpha plus iota beta square plus alpha plus iota beta. Not let. That is the yes. It has discussed in the previous function. Alpha, beta, a, b, x, y, whatever. Alpha, beta means they may be any variable. You may write a, b. If you are confused with the alpha, beta, you may write as a, b. Okay. But a, b we usually don't use as a variable. As usually we use as a constant number. But I think alpha, beta is more general term. Alpha, beta means there may be x, there may be y, there may be a time, there may be a concurrent tensor, covariant, whatever that alpha, not here is concurrent covariant because they are a real number, mean they may be any variables, v square, velocity, acceleration, whatever they are variables, alpha may be different variables. So they may be x, y, or x, z, x, t, whatever that are. Okay. So, and we have already explained. So every complex numbers. Firstly, we will write in the form of the functions, which was I have to write it in the form of r alpha beta plus iota alpha beta. I have to drive in this form. Okay. So what is alpha square plus yes. A square plus b square, iota square is equal to -1, beta square plus 2 iota beta, 2 iota alpha beta plus alpha plus iota beta. So they may be right in this form. Alpha square plus alpha minus beta square, yes. Alpha square minus alpha plus alpha and beta plus iota 2 alpha beta plus beta, yes. Iota alpha beta 2 alpha beta plus beta. So this is Fc, and this is R, this is this is this. Okay. So what you will get if you differentiate partial R over partial alpha, yes. Partial derivative, beta will be treated as constant. Okay, so this will be a 2 alpha plus 1 partial R over partial I over partial alpha, yes. I alpha 2 yes 2 beta, yes. Partial I over partial beta will be 2 alpha plus 1. Okay, so this will be equal to this, yes. Okay, yes. Partial R over partial partial I over partial alpha, yes. Alpha, yes. 2 beta, but okay, 2 beta only, and partial R over partial beta. Yes, this is minus 2 beta. Okay. 1, 2, 3, and 4. 1 minute. Okay. These are the 1, 2, and 3. 1 and 2 implies that partial R over partial alpha is equal to partial I over partial beta. Yes? And 3 and 4, what 3 and 4 implies? Partial I over partial alpha is equal to partial R over partial beta. So these are the Cauchy-Riemann equations, and it is satisfying these Cauchy-Riemann equations. So that means these are this is the analytic function. So first is the analytic function. Got it? That is very simple. Okay. Now the we move toward the next. Not let. This is a real part. I think you have not attended the last lecture. This is R. This is means this is as I have already explained that every complex function may write in the form of their real and imaginary part, but they are both are real numbers. But this second part will be multiplied with the like a complex number. Okay, so this is R and this is. Okay, please attend the go to the last lectures. Okay, that is about this. Okay, so this will be your result. Okay. Okay. Next is. So this is equal to, yes, please. C is alpha plus iota beta exponential of minus alpha plus iota beta. Okay. And this may write as alpha plus iota beta. Yeah. Now, C is alpha plus, this is different axis. C exponential of minus C. Okay. And E will be minus alpha minus iota beta. Please इसको थोड़ा देर रहने दो, ठीक है, डिस्टर्ब कर रहा, प्लीज. आपके पास ये क्या आ जाएगा? C is alpha plus iota beta minus alpha. This will be equal to this minus beta, iota beta. Okay. And this will be yes, alpha plus iota beta E minus alpha cos beta minus iota sin beta. Okay. Sin cos beta minus iota sin beta. And this may write as alpha, this may as write minus E alpha cos beta alpha will be multiplied with this exponential of minus alpha cos beta. When this multiply with the iota minus is minus, iota square is equal to minus 1. This will be a plus, yes, beta E minus alpha because sin beta. Okay. So this will be a real term. What will be the imaginary term? That will be alpha minus iota alpha sine beta, alpha minus iota alpha sine beta plus iota beta minus alpha cos beta, or you may say that yes, e की power alpha. 1 minute. Okay. When alpha is multiplied with this, e minus alpha cos, this is real term. When this multiply with this will be iota square, and that will be a minus 1, so that will become a minus plus beta e alpha sine beta. The other term is iota will multiply with this, alpha multiply with this minus iota alpha, I have taken the common, minus alpha iota alpha sine beta, and then when it multiply this, then this will be a beta e minus alpha cos beta. Okay, so this will be a term. Okay, this is your this will be your R, and this will be your I. Okay. Partial R over partial alpha. Yes, what is this? This is real term. Product formula will be applied because E alpha. Okay. Firstly, E minus alpha cos, I have taken derivative with respect to alpha. That will be a cos beta minus derivative of E alpha is alpha. E alpha and alpha derivative is minus, so that will be a minus E alpha cos beta. Okay, and now this term with respect to alpha, this will be a minus beta E minus alpha sine beta. This is derivative with respect to alpha. Okay. Partial I over partial alpha. What is this? Oh, sorry. Partial I over beta. Yes. Yes. What is this? With respect to beta. Okay. Minus alpha E minus alpha cos beta, sine derivative cos beta, plus E minus alpha cos beta minus beta E minus alpha sine beta. Now minus beta, this and this is same. Okay. So R partial alpha is equal to partial I C1. Okay. Now about the second condition. Partial R over partial beta. Yes. Yes. What will be the second condition? Partial R over partial beta. Okay. E minus alpha, alpha minus sine beta. Derivative of cos is minus sine, plus E minus alpha sine beta minus beta E minus alpha. This we are taking derivative beta as it, derivative of E alpha. Yes, you are right. Plus beta E minus alpha, derivative of sine beta will be cos beta. Okay. Yes. Partial I over partial alpha. This is I minus common with respect to alpha. Firstly, we take derivative with respect to alpha. Sine beta. Firstly, we write it as it alpha. Okay, minus is multiplying with it. Okay, alpha. This will be a plus. Okay. माइनस अभी कॉमन नहीं लेते, चेक करें. Minus, okay. We are taking derivative with respect to alpha. Okay. E minus alpha sine beta. Okay, and minus plus alpha as it E minus alpha sine beta, derivative with respect to, we are taking derivative with respect to, plus minus beta E minus alpha cos beta. Okay. Here. Okay. So now we compare minus E alpha. This is minus. This is plus. This is minus. This is plus. This is minus. This is plus. So partial R over partial beta is equal to minus partial I over partial alpha. So C2 is satisfied. So this is also an analytic function. Very important question, because there is it will teach you how we divide it into the real and imaginary. So that's also analytic function.
As mentioned, the exercises about the verify the following expression are analytic by using the Cauchy-Riemann equation. Let's start from the first equation, that is uh, if C is equal to sine 2C, that is uh, as we know that C mean a complex number, that complex variable, that is alpha, iota, beta. Alpha and beta are two complex numbers. Uh, both are real, but alpha is along the real axis and beta is along the imaginary axis, and so we may write as uh, sine 2 alpha plus 2 iota beta, and it will be equal to sine uh, 2 alpha cos 2 iota beta plus uh, cos 2 alpha sine 2 iota beta. Okay, and as we know that uh, where the sine iota theta is equal to iota sine hyperbolic theta, while cos iota theta is equal to cos hyperbolic theta. We will use this formula, okay, on above equation. So your result become sine 2 alpha cos hyperbolic 2 beta plus cos 2 alpha sine hyperbolic, sorry, here will be a iota, because sine iota theta is equal to iota sine. Uh, so this will be result hyperbolic to theta. Okay. This this is your R, and this will be your I. Okay. So they say that oh, partial R over partial alpha, that will be from this sine derivative was 2 cos 2 alpha cos hyperbolic 2 beta, and partial I over partial beta, that must be same if they are this is okay. So this will be when we take a derivative, this with respect to beta, for derivative of cos 2 cos 2 2 alpha will be as it. Uh, Derivative of sine hyperbolic 2 beta will be plus 2 sine uh, cos hyperbolic 2 beta. Since both results are same, so it means uh, partial R over partial alpha is equal to partial I over partial beta. So C1 is satisfied. Okay. The next condition is about uh, that was about if we consider there was if we uh, partial r over partial beta. We can take derivative with respect to beta. This r. So this will become again 2 sine because we are taking derivative with respect to beta. So this will be a sine hyperbolic 2 beta. But partial I over partial beta will be equal to, yes, when we take derivative. So not with respect to beta, but with respect to L, we have to consider with respect to alpha. Then this will become 2 minus sine 2 alpha cos hyperbolic 2 beta. From these two equations, you may see that this the second condition, that is r over beta must be equal to minus partial I over partial alpha, which is C2, is also satisfied. So, accept this. Right. So this implies that because C1 and C2 for FC equal to time to C is satisfied. This implies that it is analytic function. Same, this exercise will be same. The procedure will be applied for the second exercise. Okay, now we will do the second exercise with same procedure. Okay, the same procedure will be applied on this the second. Uh, Now we'll perform a second exercise, that is if Fc is exponential of iota c, that mean because as we know that E iota theta is cos theta plus iota sine theta, if we try to solve this. So this means iota c, so that is iota alpha plus iota beta. Okay, see. So this means this is now we will uh, try to solve the second expression the same way as I have solved the first equation, first exercise. So uh, let's start. If we consider that Fc is exponential of iota c, mean e power ic, where again c is iota alpha plus iota beta. Okay. As we know that the iota uh, we know that E iota theta is equal to cos theta plus iota sin theta. So, you will get FC will be equal to cos alpha plus iota sin iota. Oh, sorry. No, same procedure we will apply for the second exercise. So let's start. FC is equal to exponential of uh, iota c, where c is a complex number. Okay, so exponential of iota alpha plus iota beta. But we know that iota theta is equal to cos theta. Exponential of iota theta is equal to iota sin theta. So, this will be equal to cos alpha plus iota beta plus iota sin alpha plus iota beta. Yes, and the product formula will be applied. Okay, cos alpha plus beta is cos alpha cos iota beta minus sin alpha sin iota beta plus iota sin is sin alpha sin iota beta. Oh no, sorry. Sin alpha cos iota beta. There will be plus sign. Plus sin iota beta cos alpha. Angle will be replaced with each other. Okay. Sin alpha cos iota beta plus sin iota beta cos alpha. Okay. So as we know that cos iota beta is cos hyperbolic beta, while sin iota theta is not sin hyperbolic, but here will be iota will become sin hyperbolic theta. We will apply this formula on above equation. So, our result will be, yes, that will be a cos alpha cos hyperbolic beta minus sin alpha sin hyperbolic beta plus iota sin Here will be iota because sine iota beta is equal to iota sine hyperbolic beta. Similarly, iota sine alpha cos hyperbolic beta plus iota sine hyperbolic beta cos alpha. Okay. So we will separate the real and imaginary part of this. Mean R and so that will be a cos alpha cos hyperbolic beta. Yes, and the when we multiply with this iota with this iota multiplied by iota will be a minus. So you will have minus, yes, minus sine, yes, uh, minus sine alpha, yes. So sorry, iota will be multiplied with this. This will be yes, this will be a so this will be a minus sine hyperbolic beta, yes, sine hyperbolic beta and cos alpha. This will be one result, and other will be this minus and this. If we take a minus common, minus iota, okay. If I take minus common from this become a minus sine alpha, yes, sine hyperbolic beta, and this iota will be multiplied with sorry this, and this is a plus term, but when I have taken the minus iota common, this will be here will be a minus, yes, that will be a minus sine alpha cos hyperbolic beta, yes. So this will be your R, and this will be your I. Okay, always remember it. Okay, and this will be your R. Minus iota sin alpha cos hyperbolic beta minus sin alpha cos hyperbolic beta. This will be your I. Okay, so now it is easy to solve. Okay, okay. So how we will solve it? Uh, Firstly, we take a derivative. Sorry, we will take derivative of partial r over partial alpha. Okay, with respect to firstly we take derivative of r with respect to alpha. Derivative of cos is minus. Okay, minus sine alpha co, cos hyperbolic. Yes, cos hyperbolic beta will be as it because we are beta will be treated as a constant. Minus sine yes, minus sine hyperbolic beta. The derivative of cos theta is minus sine, so this will be a sine alpha, and this will become a plus. Okay, this is partial r or partial alpha. Now we have to find partial I over partial beta. Yes, if they are same, then C1 will be satisfied. If Okay, when this is I, okay, this is our I. So minus is common. Okay. Uh, okay, no, this minus is common. So minus sine alpha, yes, minus sine alpha. Derivative with respect to this derivative of sine hyperbolic beta is a cos hyperbolic beta. Okay, and plus because minus is multiplying with the minus plus sine alpha. Because we are not taking derivative with respect to alpha, that will be a sine alpha. Derivative cos hyperbolic is sine hyperbolic beta. Okay, so the C1 is this is C1 satisfied. Now let's see what's the second condition will be satisfied or not. Now we take the derivative of r with respect to, instead of with respect to alpha, we will take the derivative with respect to beta. If we take derivative with respect to beta, then cos alpha, derivative of cos hyperbolic beta is the sine hyperbolic beta, yes. Okay, and minus derivative of sine hyperbolic is cos hyperbolic beta, and cos alpha will be same because we are not taking derivative with respect to alpha, but this is a partial derivative and we are considering alpha will be constant in this case. But if we consider the I over partial alpha, if now we take derivative of I with respect to alpha, okay, minus is common, okay, okay. Derivative of sine will be cos alpha. Derivative of sine hyperbolic beta will be as a constant. So there will be no change. Minus derivative of sine alpha is cos alpha. Yes, and derivative of cos hyperbolic beta cos that will be remain as it because this uh, beta will be stated constant for partial derivative with respect to alpha. So the C2 will also satisfy. From C1 and C2, so this implies that uh, so C1 and C2 is satisfied. This implies that exponential of theta C is also function. For today, it is okay. We have uh, verified that both given functions are analytic. Thank you very much.